So thank you, Andrew, and thank you. Once again, thank you. I'll start already. So we all know that the Holstein breed is a prime example of a really globalized breeding program. And each national program is, of course, trying to do some domestic selection, but almost any population is trying to import some good genetics from other countries, either via animals, semen, or embryos, or whatever material. And they're using that in order to upgrade their population to catch up with others. And they also try to supplement their national selection. And there are also countries who tend to rely on import solely, so they don't have their own selection. And in such situation, it's really vital to assess what's the contribution of national selection versus foreign selection in order to strategically allocate resources that we have. We all know we have limited resources. And last year we came up with a method that can be used for such an assessment. And last year we tried that on brown Swiss data. And this year we did it on a Holstein data. And in comparison to last year, we are doing analysis on the global level. That means the whole breeding, the whole worldwide breeding population, as well as doing projection on a national scale. So just briefly to describe the method, what we are doing is, I'm showing here a small example of a pedigree. And imagine that the animals in blue are coming from country X, and animals in red are coming from country Y. So what we do is, and we are interested in what's the contribution of those two countries in animal E, and we can partition the breeding value of that animal into contribution of both parents. So this would be 1/2 of breeding value from parent A and C, and 1/2 of breeding value from parent D, and of course the Mendelian sampling of animal E. And doing this in a recursive fashion, we can do it. We can see the contribution of Mendelian sampling terms for all the ancestors. And if we sum up those contributions according to from which country they come, we can split the breeding value or partition the breeding value into breeding value that should be specific just for one country. And what this equation also shows is that the breeding is really a long-term job, because in each animal we are collecting the Mendelian sampling terms of all the previous ancestors. If you think this through genes, it doesn't make sense, because for example, I got genes just from my father and parent, but the values of those genes are determined by the whole population. So we sent out a call to various countries, and 4 countries replied. This is the USA, Great Britain, Ireland, and New Zealand. And for those countries, we obtained the interval maze data for all the traits that these countries participate in the interval. This is altogether 37 traits. We did analysis for all those traits, but what I'm going to show you today, it's only the analysis for the total merit index. And we were able to compute the total merit index for about 150,000 bulls. And I have to mention that for some of those bulls, when you want to calculate total merit index, because some traits are missing, you cannot do it. So we filled in, or we imputed those breeding values as an average breeding value of bulls born in that year. And you might question this, but when we compare the results, the general picture is much the same. Only because we are imputing the averages, the trends goes a little bit down, but the general picture, the general results are the same. And as additional source of information, we used number of bulls, a number of daughters per bull in a specific country, so that we were able to project the global trend to a national scale. And below you can see the number of bulls for which we had information for each particular country. So just to briefly describe the analysis workflow, so we took the maze file, for example, on the Irish scale. We took the breeding values and we partitioned them So each breeding valley gets partitioned into various country contributions. The file then, if file is like that, then it gets like that. It really gets big. And then we can summarize those global partitions and do some plots, as you'll see later. But we can also take those partitions and we can weight them by the number of daughters per bull. So we would kind of have a local projection, and then we can summarize that. So for each country, I'm going to show you two plots, the global one and the local one. So these are the results for the global for the global breeding population as viewed from the USA total merit index perspective. So you see the selection, of course, it does work. The black line shows the total genetic trend. And if we partition this into contribution of various countries, I'm only showing the 5 countries or 5 origins that contributed the most. Otherwise, the graphs are, you can't see much. So you see a large contribution from United States of America, then a little bit contribution from Canada, Netherlands, and even less from Germany and France. And I have to state this is a global overview. So if we project this to a national scale, we see that the contribution of USA is much bigger, as probably is expected. If we take a look at the UK results, we might say that the results are not that much different as compared to USA. So I'm gonna skip a little bit further, but take in mind that the genetic gain, the total genetic gain since 80s is 2 standard deviations of the total merit index. And if we take a look at the projection of a local scale, the picture is quite a lot similar. But as we can see is that even though the UK is relying quite a lot on import, they are doing better job because the total genetic trend, the total genetic gain is bigger. It's almost 3 standard deviations. So even though that some country can rely a lot on import, they can do more genetic gain as the whole global population. And of course, when you come to the national analysis, each country is going to contribute at least something, as you can see also for the UK here. Now I'm going to show you a slide for Ireland, which is quite a bit of a surprise. So the global genetic trend for Irish total merit index, called EBI, is negative, and this was quite a surprise. But if we take a look at the construction of the index, I didn't show the weights. It can be nicely explained. There in the Irish index, there is a quite large weight for fertility, somatic cell count, and longevity. And as you know, for all those 3 traits, the genetic trends were quite low. I'm sorry, guys, from the United States, but it seems that this is mainly due to the breeding work that you are doing, a little bit from Canada, but other countries seems to be balancing a little bit the situation, or not contributing a lot. But when we project this to a national scale, we see that the black line, it is increasing, so Ireland is doing something to prevent this. And even when they import semen from United States, they try to import those bulls that tend to improve these traits a little bit. But on the overall, if you take a look in these trends, we see that on the global, the Netherlands and New Zealand and Ireland, they're also adding something to this positive trend in recent years. And lastly, the global trend for the New Zealand total merit index, called breeding worth. So selection is also effective in that part of as viewed from that part of the world. And here, because they have different emphasis on other traits, we see that the contribution of United States is a little bit smaller. And when we project these results to the national scale, New Zealand is contributing most of it, and this can be explained due to the fact that their production system is much more different, because in practice, what they mainly use their domestic bulls via collecting fresh semen and having those seasonal inseminations. And the contributions from other countries are much smaller. So to sum up, There is a major influence of genetics coming from United States on a global scale, which is expected. It is a little bit in this line, but still by far the greatest. There are some countries who rely a lot on import, but with that, if they pick the bulls that really match to their breeding program, they can get faster genetic gain as they would do it just on a local scale. And there are also countries that need to be very careful about using bulls. For example, that's New Zealand and Ireland, because they have different trade emphasis. And it seems that New Zealand really capitalized on their domestic infrastructure, on their breeding work done at home. But it seems that Ireland lost a little bit of opportunity in some period of time, but they are fast recovering in recent years. Thank you.